Okay, so this is regarding thermochemistry, this problem, and it is a problem where we are using our specific heat equation. And the first step, as always, is to identify our givens. So if we want to identify our givens, we see here that we have 164 grams of metal. It's heated to 90 degrees C, and then it's placed in 300 grams of water. T initial is 10 degrees C. After the metal is added, the water temperature rises to 11.3 degrees C. And then identify the metal, and they give you a list of specific heat capacities. And we can see here which metal this metal would be based on its specific heat capacity, because specific heat capacity is characteristic of a given element. Now, how would we handle this problem? We did our givens. Now we have to see what are we looking for. So what are we looking for here? It says to identify the metal. And we do that by finding its specific heat capacity. To find a specific heat capacity, we know that we have the Q equation. Q equals mc delta T. We can start with, it says here, calculate the heat energy released to the surroundings as the metal cools from 90 degrees to 11.3 degrees C. So first we have to figure out, do we have energy? And we don't have energy here. But what we do we have the mass of the water? We have the mass of the water. Do we know the specific heat of water? That's a standard value of specific heat capacity, so we know the specific heat of water. Do we know the temperature change for the water? We do. Final temperature is 11.3, initial temperature is 10.0. So we know enough to get the Q, the heat energy for the water. The heat energy for the water, or the heat that's being released into the water, will be the same amount of energy that is released from the metal as it cools. So if we do this problem in two steps, we can figure out the specific heat capacity of the metal. So the first step would be to find the Q for the water. So let's go ahead and find the Q for the water. So the Q for the water, we would do Q is equal to the mass of the water, which is 300 grams, times the specific heat capacity of the water, which is 4.184 joules per grams degrees C, times the delta T. Remember, delta T is the final temperature minus the initial temperature. So that's just going to be 1.3 centigrade degrees. So this right here gives us our Q for the water. The grams cancel, the degree Celsius cancel, and we're left with, if you put this in your calculator, 1,631 joules. So now we have our Q for this system. And what we can do now is go ahead and calculate the specific heat capacity of the metal. So we still have the same equation, Q equals mc delta T, but now we're using it for the metal. We put in 1,631 joules is equal to the mass of the metal, which is 164.6 grams. C is what we're looking for, because C is going to be the specific heat capacity for the metal. That's what we don't know. And then delta T is just now 90 degrees was its initial temperature, or the high temperature, and then that's its final temperature. So because it's a delta, we can go ahead and take the absolute value. And we are going to get 164 grams, that 164.6 grams times C times 78.7. Then what we have to do to get C by itself is divide by the numbers that are being multiplied by C by both sides. Which you can either put those in your calculator. So then what we have here, we put in all of our units. We have joules up here, we have grams, we have centigrade degrees. And when you put this in your calculator, these of course cancel out. And when you put these numbers in your calculator, you end up with B. And the units are in joules, grams per degrees.